Hey kiddos, today we're going to do assignment number 9, which is y equals mx plus b. Woo! That's the equation of a straight line. Today we're going to focus on the letter m, which you might remember means slope. Okay, let's get to it. So we have 3 different slopes here and 3 different sports balls. Let's say I was to release all of these sports balls at the exact same time. Which one would roll faster? And how do you know? Take a guess. If you guessed the baseball, you are correct. Now, why does that roll the fastest? Because it's on a steeper slope. Steeper meaning more vertical, more up and down, kind of like the hill from 3rd Avenue to Lex versus the soccer ball, which is flatter, which is more like the lack of hill from 1st to 2nd Avenue. Okay, so let's talk about the 4 types of slopes. The first one we have is when a skateboarder is going downhill. Any line that's going downhill like that is going to have a negative sign in front of it, called a negative slope, or decreasing, if you want to get all sciencey. The second kind of slope is the kind that Bart Simpson is skating on, although he's not really skating because he has come to a stop, because that is a 0 slope. It's not going up, it's not going down, so it's not positive or negative. It's 0. And then the third kind is when our skateboarder is going uphill. That's going to be a positive slope. You're not going to really see a plus sign in front of it because you can just assume numbers without a symbol are positive. Then our fourth kind, that would cause a skateboarder to just fall into the abyss and get hurt because there is no slope there. It is also known as undefined. So let's see if you can pick out the 4 types of slopes. All right, cool beans. Let's move on to actually finding the slope. So this is everyone's favorite fraction, rise over run. In order to calculate slope from 2 points on a graph, you want to first of all have 2 good points, meaning that you don't want to be in between boxes. You want to be right on the grid lines of the graph. If you're in between boxes, you're not going to be able to count anything because it's going to be some kind of fraction or decimal that your eyeball can't really pick up. So what I'm going to do is I'm going to start low. I'm going to start at the low point of the graph, and I'm going to go to that higher point right there. I want to use points that are next to each other. That third one's kind of far off, and it's going to make my numbers bigger for no reason. So I start at the low point, and I count how many boxes I rise, which is 3. The top of my fraction is going to be 3. Now from that location, I count how many boxes I run, which is 2. So the bottom of my fraction would be 2. One more thing you got to keep in mind, I know, is this slope positive or negative? Because I know it's not flat, and I know it's not vertical. So what I do is I start from the left side of my line, which is way up top there, and I trace it down. I see that it's clearly going downhill. Remember, any slope going downhill has a negative sign in front. And then you're all done. Now you try. Okay. Here we have 3 different graphs and 3 different slopes to choose from. What you want to do is be a smart test taker. What do you notice first about these lines, and what do you notice about these slopes? Well, I know there's only one negative slope and one negative graph. So since those 2 are positive, they can't possibly be negative 3 over 2. Here's where that 3 and that 2 come from. From that low point, you rise 3. And you run 2, so negative 3 over 2. That one's gone. Now let's see if we can match the other 2 slopes. Let's look at our purple graph, the first one. I start at the low point. I count 1 box up. I rise 1, and then I end up running 2, and it's positive, so it's going to be positive 1 over 2. And then that leaves our last graph. Let's review. Start at the low point. I rise 3. I run 1, so that's going to be 3 over 1. And you could write this slope as 3 over 1. More commonly, it's just going to be written as a regular 3. So let's see if you can pick out different graphs of different slopes. Okay, our next super fun example is a graph with different slopes in the same graph, and they're asking you about an interval and the greatest rate of change. Like, what does all this mean? Well, first of all, Rate of change is just a fancy, tricky way of saying slope. And an interval is just a start and a stop. So for example, the interval for school, if you can remember, was from 9 to 4:07, a start and a stop. So what they might ask you is, where's the steepest slope? Where's the flattest slope? There's a word in here that tells you if they want the steepest or the flattest. So what do you think? Steepest or flattest? Well, the word that tells you is greatest. Greatest means steepest slope. You might already be thinking, I know exactly where the steepest slope on this graph is. Let me just break down what these choices mean. So 0 to 1, if you look at the hours, which is the x-axis there, boop, 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 would be from 0 to 1. And our next choice from 1 to 2 is going to be that next section there, which I've shown in green. And 2 to 3 would be in blue, and 3 to 4 would be in purple. So what do you think? Which section of the graph has the steepest slope? If you guessed choice 1, you are correct. Steepest meaning the most up and down, the most vertical. It starts off real steep and then it gets flatter. Now that sounds silly, but every time this kind of question has been on the regions, it's always been choice 1. So if you see a question like this and you're not sure, just go with choice 1. Okay. Let's do another type of slope question you might see. Again, I have different types of slopes on this graph. It's not really going from steepest to less steep. It's all over the place. So let's look at some keywords here. They want the time intervals. So when they ask for time intervals, we're going to be using these numbers on the bottom here. And interval meaning you need 2 numbers, a start and a stop. So the first slope they're asking about is a 0 slope. Now, if you remember, 0 slope, that was the Bart Simpson one. That was the flat slope. So there's 2 locations where there's a 0 slope, there and there. I'm going to give the intervals. So that first 0 slope starts at 2, ends at 4. So I'm going to write that as 2 to 4. The second 0 slope is from 7 to 8. So I just write it like that. You could put dashes. You could put the word to, T-O. And then the next slope that they want is 1 over 2. Now that means rise 1, run 2. If you're not sure where that would be, just pick a section of the graph and try. I want to rise 1 and run 2. So let's try the orange one. I rise 1 and I want to run 2. Oh, but I can only run 1. So that's not 1 over 2. That's just 1 over 1, which is 1. Let's try again. The last section of the graph. I rise 1. And I run 2, and it's going uphill, so it's positive, 1 over 2. Now our interval would be from 8 to 10. So I write it just like that. The next one, I love when they ask for negative slope. There's only one part of this graph that's negative. What color or interval shows the negative slope? That's going to be your purple one, and that is from 1 to 2. And then the final one, there's only one part of the graph we haven't looked at, is slope of 2. Now, 2 is really 2 over 1, which means you rise 2, run 1. That's the blue section. Rise 2, run 1. That goes from 0, which is the very beginning, to 1. And that's how you do intervals with a bunch of different slopes on a graph. Let's see if you could do it. Okay, there's one more way you can do slope, and that's using the slope formula. Now, this is not on the reference table, so you're going to have to memorize this one for the regents. It's pretty easy to remember. It's y2 minus y1 over x2 minus x1. Y goes on top because y is kind of like rise, like your y-axis. Rise over run, which looks like your x-axis. So here's how this works. You need 2 points, so that's 4 numbers because each one comes with x and y. You're going to pick an x value, and you're just going to say that's x1. It's not an exponent. It's just like a little label. That's my first x value. So that's, if negative 3 is x1, that means 5 has to be x2, or the second x value. And 4 would have to be y1. Make sure the 1's go together. And 2 would have to be y2. Okay, now that all my points are labeled, I just have to throw them into that formula, into that fraction. So I want to first plug into y2. Which number did I say is going to be y2? If you said 2, you are correct. So y2 I replaced with 2, then y1 is 4. The top of the fraction is 2 minus 4. The bottom of the fraction, x2, I said was 5. x1 I said was negative 3. Now be careful with negative numbers. Your minus sign is always there, and then that negative goes with that 3. So I want to put this in my calculator using math num up. It's going to look something like that. Keep in mind I have the minus and the negative in the bottom of the fraction. I just hit enter, and I get my decimal. If they wanted a fraction, just do math frac, and I can turn negative 0.25 into 1/4. Let's do one more example before I give you a practice question or two on this. I have a table of numbers here. What do I need to calculate? Well, first of all, I see that familiar phrase, rate of change. That means the slope. There's too many numbers here for my slope formula. I only need 4, and there's 8, so I want to read a little bit to see which numbers from the table I actually want to use and which ones I don't need. So they mention hour 2, so I need that part of the table, and hour 7, I need that part of the table, so the other parts are unnecessary. Then I want to label my x1, x2, blah, blah, blah. Now this table's on its side. I'm used to seeing them up and down, but the top of the table is going to be x. So there's 2 x values. There's 2 and 7, so I just pick one to be x1 and the other one to be x2. Now distance, the bottom of that table are your y values. I have y1 and y2. Now I'm going to plug into my formula. First thing I need is which number did I call y2? Well, that is 480. So I'm just plugging into my formula y2 minus y1. And then x2 I said was going to be 7. x1 is 2. Math num up, throw that into the calculator, and I get 68. Unfortunately, this question requires one more step. It's super easy, but they wanted you to include units. Now, a unit is basically meaning or context. Like, for example, if I'm measuring something and I say, oh, my desk is 20. Like 20 what? Feet, inches, so centimeters. So 68 what? So I actually have the units in the table. There's 2 units that I used. When I was doing the top of my fraction, 480 and 140, the unit for 480 and 140 is miles. And then 7 and 2, the unit for those numbers is hours. So the units I used were miles and hours. Can anybody think of a unit that involves miles and hours? Well, for these units, if you said miles per hour, you were correct. And my answer would be 68 miles per hour. That's how you find slope. All right, so try some on your own. It's been fun. See you next time.